So by now we know what a graph is, and we know how to store it using a matrix or a list. But storing a graph is not very exciting on its own. The real magic begins when we start exploring it. So here is today's big question. You are standing on one node. From there, you can reach its neighbors. From those neighbors, you can reach more nodes. How do you visit every single node in a clean, organized way, without getting lost and without visiting anyone twice? Today we learn the first and most famous way to do it. It is called Breadth First Search, or BFS for short. And I promise by the end it is going to feel as natural as how you actually think. Let me start with something you have all seen. Imagine a stone dropped into a still pond. What happens? A ripple spreads outwards. First a small circle, then a bigger circle, then a bigger one. The ripple touches everything close by first and only then moves further out. That is exactly how BFS explores a graph. It spreads out level by level. First it visits everything one step away, then everything 2 steps away, then 3. Like ripples in a pond moving outward in rings. Let me give you an even more relatable picture. Think about how news spreads in your friend circle. Say something exciting happens to you. First you tell your closest friends, the people directly connected to you. Then those friends tell their friends. Then those friends tell theirs. The news travels outward one layer at a time. Nobody 2 steps away hears it before the people 1 step away. That layer by layer spreading is the heart of BFS. Closest first, then the next ring, then the next. Now to do this properly, BFS needs one simple helper, and you already know it from real life. It is called a queue. Think of a queue exactly like a line outside a cinema or at a railway booking counter. The first person to join the line is the first person to be served. First in, first out. That is all a queue is. We add people at the back and we serve them from the front. Here is how BFS uses this queue. We begin at our starting node. We put it in the queue. Then we repeat one simple cycle again and again. Take the person at the front of the queue, look at all their direct neighbors and add any neighbor we have not seen yet to the back of the queue. Then we move on to the next person at the front. Because we always serve from the front and add to the back, the nearest nodes naturally get explored first. The queue quietly keeps everything in perfect ripple order without us having to think about it. But there is one important thing we must take care of. In a graph, 2 friends can both be connected to the same person. So we might reach the same node from 2 different directions. If we are not careful, we will visit it twice and possibly go round and round forever. So BFS keeps a simple visited list. The moment we see a node for the first time, we mark it as visited. And before adding any node to the queue, we check, have we seen this one already? If yes, we skip it. This little check is what keeps BFS safe and clean. No repeats, no infinite loops. Now let us read the code and actually watch it run step by step. It is short, and every line maps to something we have already seen. We have a function that takes 2 things, v, the number of nodes, and adj, the adjacency list that holds every node's neighbors. This list, BFS, is where we collect the nodes in the order we visit them. It is the answer we will return at the end. This Boolean array remembers which nodes we have already seen. It is what stops us from ever visiting the same node twice. And this queue is our waiting line. It is the helper that drives the whole search front to back. We begin by adding our starting node, node 0, into the queue. And right away we mark 0 as visited, so it can never be added a second time. Now the main loop begins. It keeps running as long as the queue still has someone waiting in it. We take the node at the front, 0, and record it into our answer. This is the order in which BFS visits the graph. Then we look at 0's neighbors, 1 and 2. Both are new, so we mark them visited and add them to the back of the queue. The loop runs again. This time we take 1 from the front and look at its neighbor 3. 3 is new, so we mark it and add it. Next we take 2 and we reach 4. 4 has not been seen before, so it joins the queue as well. Now we take 3. All of its neighbors are already visited, so nothing new is added. And the very same thing happens for 4. And now the queue is finally empty, so the loop stops. The order we collected, 0, 1, 2, 3, and 4, is our breadth-first traversal. And if you prefer C++ or C, do not worry. The idea is exactly the same, only the syntax changes. Watch, the very same logic just transforms into C++ and then into C. Let us talk briefly about speed. BFS visits every node once and looks at every connection once. So the time it takes grows with the number of nodes plus the number of edges. In plain words, it is very efficient. It does exactly the work it needs and not a bit more. And one beautiful bonus. Because BFS explores layer by layer, closest first, it has a special power. In an unweighted graph, where every connection counts the same, BFS naturally finds the shortest path from your starting point to any other node. Think about it. The first time the ripple reaches a node, it has reached it by the shortest possible number of steps. That is why BFS quietly powers things like finding the fewest connections between two people on a social network. Let us bring it all together. BFS explores a graph like ripples in a pond, level by level, closest first. It uses a queue to keep that order, first in, first out. It uses a visited list so nothing is explored twice. And as a bonus, on an unweighted graph, it finds the shortest path. That is a lot of power from one simple idea. And just like that, you understand breadth-first search. Not as a scary algorithm, but as something as natural as news spreading through your friends. Next time, we will look at the other famous way to explore a graph, its adventurous cousin, depth-first search, or DFS. Instead of spreading out in calm ripples, it dives as deep as it possibly can down one path before coming back. It is a completely different personality, and once you see both, you will know exactly when to use which. So, see you there.